So before I continue with the expansions notebook, I have to go back and show you a few slides about something that I missed in the previous lecture. And so there is a deck of lecture slides that talks about file permissions. At the beginning of that deck of lecture slides, it talks about something called a T. And I neglected to show you that. And so I'm going to talk about T's very quickly. We've already done the file permissions, so I'll jump back to the expansion notebook after I talk about T's. So the T part really should have come when I was talking about, or I should have talked about it when I was talking about redirection. So redirection allows you to send the output of a command to a file, right? So you use the greater than or greater than operator that lets you send the output of the command, either the standard output or the standard error output to a file, or both if you wanted to. So that lets you send output to a file. And piping lets you send output to a command. And so you can easily come up with situations when you want to do both, right? I would like to send the output to a file, but I want to continue sending that output further down a pipeline so that other commands can process that information, right? And so you might want to save the file, you might want to save the output to a file so that you have the intermediate result of a step in your pipeline, right? But you want the rest of the pipeline to continue processing. Similarly, further down the pipeline, you might want to save another intermediate result to a file and then continue processing. So there needs to be a mechanism, or it'd be nice if there was a mechanism that lets you do both, and there is, and that's called a T. And so this is a picture of a T. So here, T is a command, right? And so it's a special type of command. So it takes some input, right? It simply passes that input to its output. Right? So it just lets the input flow through the pipe and go further to the next stage of the pipeline. Right? And it sends that output to its standard output. So you could have another pipe section here that takes the standard output as input. But it also redirects whatever input it got and sends it to a file. Right? So this lets you do, this lets you continue the pipeline. Sorry, I have a busted control key. Okay, so this lets you send the this lets you continue sending the output from this pipe from this command further down the pipe, and it also lets you save whatever this output was to a file. Right, and so the T command is it's particularly useful when you're trying to save intermediate results of a pipeline to a file or files. Right, and so here's a set of examples that all use T to save the output of the date command. So date on its own simply prints out the date in some format. Date is one of the commands that's different on Mac compared to Linux. So the Mac version of date outputs will generate output in a different way, and its options are all different. So that's one of the commands you have to watch out for. So here I'm going to take the output of date, I'm going to pipe it to a T. Right? So remember what this does. So the T will send whatever output from date it got from date, and it'll send it to the file full date.txt. And then on T's standard output will appear whatever input it got from date. So this will print, the output of date and also save it to a file. So if we do that in a terminal somewhere, so date on its own prints out a date like that, right? If I pipe that to T, and save the output to some date.txt, we still get the output from date. And we also have saved that output in a file at the same time, right? So there's no way you can do this with just a simple redirect in a pipe, right? It won't let you do that. So in other words, you can't redirect the output of date using the greater than operator and then try to pipe its output to some other command. Okay, next example, we're gonna do the same thing. And then I'm gonna use cut. And I'm going to try to extract, it looks like field number 1 from the date. So you should have used cut on your first assignment, so you should be able to read this or at least guess at what this does. Right? Cut is a command that cuts cuts output that is separated, in this case with a space, and it breaks that up into separate fields. So if you have a string that you pass to cut and it's got a bunch of spaces in it, cut will let you extract one or more of those strings. Right? And you do that by telling it which fields you want. Right? So fields equals 1 means give me the first field. Okay, so let's go back and look at date. So date outputs something that looks like that on my computer. right? And so you have the days with a space, then the month with a space, and so on and so on and so forth. If I want to get out just the date, or sorry, the day, I can use cut to do that. So cut minus delimiter. Minus delimiter, the short form is minus D. I need a space, and then I want the field number 1. So there, that lets me get the day of the week, Tuesday. If you want the second field, you can get that, right? So if you wanted the month, it's just minus F2, right? And so on, and so on, and so forth, right? So there's just an example of using writing a pipeline that uses T to store the intermediate results, right? From your assignment, you should have realized that you can pass the output of cut to another instance of cut. So you can cut you can cut the output of cut itself. Right? So you can use cut once to extract a bunch of columns, and then you can use cut again to extract a particular column from that, which might be useful, or at least was useful on the assignment. And you can insert a T anywhere you want into a pipeline, because T is just a command, so there's nothing special about it other than it also redirects its input to a file. So here I can run fortune to generate a random fortune. Right? I can save the fortune in a file. I can also print the fortune using Causa, right? Or try to print it using Causa, but instead of printing it using Causa, I can send that output to a file, right? So still nothing's going to appear on standard output yet, right? And then I'm going to pipe the output of that T to another instance of Causa. And so if you type in all of that, you end up with a cow that speaks, a cow that prints out stuff, that's a cow that prints out the fortune. Right, so you can try typing that into your console and see what you get if you have fortune and Causa installed. Right, that minus and then the space and the N is all deliberate. That actually means something. You can look at the man page for Causa to find out what it actually means. All right, so that's those are T's. Right, so the T is just a command. Right, what does it do? It takes its standard input, echoes it to standard output, but it also redirects whatever it got from standard input from its input. To a file. Right. Okay, so let's go back to the expansion notebook. Oops, sorry, I'm just going to check if I'm in the right directory. I am not. Okay. All right, so the first expansion that we saw yesterday was the brace expansion, right? So remember, so first of all, what does an expansion do? Right, so an expansion is some text that the shell interprets that has a special meaning to the shell, right? The shell takes that text and replaces it with the result of expanding that text. So we saw the brace expansion in the previous lecture. We've seen the tilde expansion already, right? I've actually shown it to you several times now, right? So remember, tilde expands to the absolute path of the user's home directory. So for example, I can print the name of my home directory by writing echo tilde. And so when you do this, remember what the expansion does, right? So the tilde actually expands to the name of my home directory. So when you write echo tilde, the shell replaces the tilde with the name of my home directory, right? And that is effectively the command that gets run, right? Okay, so if there are multiple users on the system, then you can use tilde username to get the absolute path of that particular username. So here, tilde sys220, I don't know if this works. Oh, no, it doesn't work. All right, so I think it's Homer Simpson on this computer. Yes, okay. So tilde, some username, prints the home directory of that username, right? And so here, all of this gets replaced with all of that. So it was exactly as if you had typed in, home, like that, right? And then it prints that. Okay, if you wonder why tilde exists, you might say, well, everybody's name is just in root home. That's not true. You can actually, it's possible to set your home directory so that it's somewhere else on your file system. Okay, so parameter expansion gets its own notebook because there's many types of parameter expansions, and I don't tell you about all of them in this course. There's just too many of them. So we'll come to that probably later in this lecture. So the next one, we're going to skip over that for the time being. So there's something called command substitution. The word substitution is often, sometimes is used instead of expansion, but they mean the same thing, right? So this is still another expansion. So what command substitution does is it allows the output of the command to replace the command itself. Right? So here I've got, so it takes the form of dollar and then round bracket, closing round bracket, and then the command inside the round brackets. Right? And so what happens is, when you write something like that, this command gets run, right? It doesn't run in the current shell. What the shell actually does is it spawns a new shell, runs the command in the new shell. Whatever output it generates is then returned back to the current shell. The subshell gets shut down, and the output now appears and replaces all of that, right? So whatever the output of command is, that just gets dropped in for all, and replaces everything that I've got highlighted there. Right, so you can use a command. One use of command substitution is to store the output of a command in a variable. Right, so you imagine you have some command, it outputs some result. Right, normally the result gets sent to standard output. Right, how do I store that in a variable? Command substitution. Right. So here's an example from this link here. This link is useful. So it's hard to remember because it's mywikiwoolidge.org. It doesn't really tell you what it is. This is a set of web pages written by one person, I believe, that has many answers about Bash. Right. So if you're ever wondering, if you ever have some question that might you think that people are often asking, that's a good place to look. The answer is probably there. Right. Okay. So here's an example of using two command substitutions. Inside with the echo command. So if you're on a Mac, again, this may not work, or it may not give you the output that I'm going to generate. So let's run the command first and let's see what happens. Okay, so this prints out today is Tuesday. It's currently 9:58. It's not. It's like 10:43. Right. Okay, so what's going on here? So when Bash sees this, right? When your shell sees that, it sees there's a command here. Right. Then it sees there's a space. Right, and then it sees there's a string here, right? So it looks inside the string and it sees there's a bunch of text, but it also sees a command substitution, right? Now, the double quotes here are important, right? So if you remember back 2 lectures, right, you know that if you have unusual characters in a string, you can use single quotes, double quotes, or the backslash to escape the special characters, right? The single quotes and double quotes do something different though, right? Single quotes removes all meaning, right? Removes the meaning of all special characters inside the single quotes. So all of the characters inside the single quotes are treated literally. The double quotes removes the special meaning of many characters, right? But it does not remove the special meaning of the $sign. So Bash looks at this thing here, right? And it sees there's a command substitution. It also sees there's a second command substitution. So Bash launches a new subshell, right? Runs the date command, right? The +%a tells date to output just the day in long format. So Tuesday, not TUE, for example, right? Runs another subshell, right? Runs the date command in the subshell, and this command here tells date to print out the current hour, followed by a colon, followed by the current minute. Right? And so the output of date replaces all of that. So that's why Tuesday shows up here, right? And the output of this version of date replaces all of that, and you get the 0958 here. Right? The order in which these 2 commands run, I believe, is not specified anywhere by the documentation. So you don't know if this command is going to finish first or if that command will finish first. So don't rely on the output of this to try to feed it to the output of that. Right? In particular, if this writes to a file, there's no guarantee that this second command will be able to read the file that was output by the first command. Right? Okay, so there's an example of using a command substitution inside by using a command substitution and taking its output and inserting it into a string. Right, so that's one way to do that. The other common use of a command substitution is to store the result in a variable somewhere. Right, and so most commands simply generate output. The output's just a string. Right, so it makes sense that you might want to store that string somewhere and process it later on. So here, when I run that, nothing appears to happen. Right, what has happened is that Bash sees there's a string here followed by an equal sign, no space. Right. If you put in the space here, you'll run into a problem. So I'll show you that in just a second. So moo, no space after the equal sign, and then there's a command substitution. So Bash runs the command, calce moo, takes its output and inserts it in replacing all of the highlighted text there. Right? And so it turns out this is a variable assignment in Bash. Right? So it makes a variable called moo, right? And assigns whatever is on the control. Whatever's on the right gets assigned to moo, right? And then you get no output, right? Okay, so if I want to process the value that's stored in moo, we can do something like this, right? So I'm going to print the string that's stored in moo. So when you want to get the value stored in a variable, you need the $ in front of the variable name. Right? You have to watch out for this. So Bash recycles a lot of its symbols for many purposes. Right? So here the $ is being recycled. Right? Here opening brace means command substitution. $ variable name means you want to get the value of the variable. Right? You want to get the value. You don't want to assign to it. When you assign to a variable, you never put the $ in front. Right? When you want to get the value of a variable, you must use the $ to get the value of the variable. Right? There's another form of this. Right? So again, we've got braces. Right? This is not a brace expansion. This is still getting the value of a variable. Right? $brace, name of the variable inside the braces, means get the value of the variable inside the braces. Right? This is the standard way. This is the quote unquote standard way to do it. But it's often not necessary to write the braces, and so many programmers will simply write it as $moo in this case. Let me go back, I'll answer your question in just a second. Back here, if you insert a space around the equal sign, right, like you probably should have done in CISC 124, or perhaps CISC 121, depending on what they told you you should be, what style guidelines you should be using, right? Bash will complain. Oh, sorry, it will complain. Right? Remember, Bash uses the space as its word separator. So Bash here sees moo, right? Then a space, right? So Bash thinks you want to run the moo command. There is no moo command on my computer, right? It then sees an equal sign, so it also treats that as what is it? Right, right? And so it wants to treat the equal sign as an input to the moo command, right? Similarly, it sees another space. It knows that's an expansion, so it wants to treat that as another argument to moo, right? And that's why it complains, moo's not found, right? Did you mean one of these, right? So you can't put the space before the equal sign. You can't put it after this. You can't put it after the equal sign either, right? So here it thinks this is a variable assignment, right? But then it sees a space, right? And now it sees this, right? And so again, it thinks there's a command. You're trying to run a command, and it doesn't know what command you're trying to run, right? So it turns out the space is often significant inside of Bash. Okay, you had a question.
My question is, when we save the variable, if we close the terminal, like the next time, does that still exist?
No. So when you close the terminal, that shuts down the shell. So when you open a new terminal, a new shell appears, and so the value that you had stored previously is gone. Yeah. Okay. So that's command substitution, right? I want to take the output of a command and I want to store it somewhere or use it as part of another expression of some kind. Okay, Bash also lets you do simple arithmetic using integers only, right? Something is wrong with this. Yes, there is a missing round bracket. Okay, So bash will let you do arithmetic. It only lets you do it with ints. If you want to do arithmetic with something involving a decimal point, you can't do it from bash natively. You have to use another command that knows how to do arithmetic with floating point values. Right? We're never going to actually try to do any arithmetic with floating point values, so you don't have to worry about that. At least not for the bash part of the course. Even arithmetic with integers is a little bit uncommon. Right? The shell is not really designed to do math. Mostly it's designed to interact with the operating system. And it's a little bit unusual to have to do math to interact with the operating system. It's sometimes useful to compute strings. So you might have strings, part of the string's a number, and you need to compute the value of that number. So that's one of its uses. It's also occasionally useful if you want to write a loop. Okay, so again, we recycle the round bracket and the dollar sign, right? So dollar sign 2 round brackets, right? And closing 2 round brackets on the other side means you want to treat whatever's inside here as though it were an integer arithmetic expression. Right? You get all of the regular operators that you get in most other languages, right? So plus, minus, multiply, divide. You also get remainder. So % is remainder in bash as well. So here, I've got the expression 1 plus 1. Inside the double round bracket, spaces don't matter anymore. Right? Bash is going to try to interpret whatever you have inside the double round brackets as being a mathematical expression. So double round bracket, dollar double round bracket 1 plus 1. Hopefully this prints out 2. It does. That's good. Right? Here's an example of when you might want to use an arithmetic expansion for some reason. So here I'm going to compute a number and use that as part of a file name. Right? Notice how this works. Right? So I've got make dir. Right? I've got the string dir. I've got no space here. Right? And I've got an arithmetic expansion. So remember what the expansion does. It computes the result of the expansion, replaces all the highlighted text. Right? So this ends up being make dir 10. Right? Make dir space dir 10. Right? The result of 2 times 5 replaces this. That's 1 and 0. Right? And so that becomes dir 1.10. Right? And notice that, oh, sorry, I shouldn't have run it in this directory. Where's dir 10? Here it is. So dir 10 gets made and gets created here. Right? So if you want to do string concatenation in bash, there's no special operator for it. Right? You just take the string, you take another string, you mash them together, and away you go. You get string concatenation. Right? Everything in bash is just a string. So all values are strings. Even things that look like numbers, right? So that looks like an integer 1. It's not. As far as bash is concerned, when you actually use that value 1, it's going to be a string, right? If you use it inside of an arithmetic expansion, it knows to interpret the string as though it was an integer, right? So here, when you have the number 10, it's just the string 10. So it concatenates that to the end of dir, and you get dir 10. So these are somewhat uncommon when you're using, definitely they are very uncommon when you're simply using the command line on its own, right? If you're going to write a script though, you might need a loop that counts. And so in that case, it's useful to have some arithmetic, right? You might need to compute a file name or some variable, some string that has a number in it. And that's another case where an arithmetic expansion would be useful. If you're writing a bash program and you think that you need to compute some floating point arithmetic, you should probably reconsider whether or not you should be using bash to write this program. Right? You're probably better off writing it in another language. All right. So after all of those expansions have occurred, right? So we have brace expansion followed by tilde expansion, followed by command substitution, followed by arithmetic expansion. Bash then performs word splitting. Oh, there's also variable or parameter substitution in there, right? So after all of those things have occurred, right, now bash looks at what has appeared, and now it starts to split stuff up using white space, right? And so the next expansion that occurs is word splitting, right? So anything not inside double quotes undergoes word splitting, right? So word splitting splits a string into separate parts or fields or tokens, is the formal name for it, right? And each field is delimited by one or more field separators, right? So word splitting occurs by default on a space or spaces, right? On a tab character or on a new line character, right? So anything that looks like white space will cause word splitting to occur. So those are your default field separators. Right. Okay, so the fact that Bash uses white space to split tokens is why you should not use spaces in file names. Right. So you may have noticed that there's a file, notice file name. Why would you have noticed this? I don't know why you would have noticed this. Is this actually in the directory? Hang on, let me see. Oh, there is. Okay, so there's a file called sys220 assignment solutions.zip, and that looks like it might contain the assignment solutions for sys220. I don't think it does. I think it's just there as bait. Right. Okay, so if you try to unzip that file, right, and you've forgotten that you should that the space is special, right, and you try to do that, you'll get some unusual output, right? My unzip command says, hey, I can't find sys220, sys220.zip, or sys220.allzip, right? And so what's happened here is that word splitting has occurred. So as far as Bash is concerned, you're trying to pass that argument, followed by that argument, followed by that argument to unzip, right? What does unzip do? Unzip tries to interpret that argument as though it were the name of a zip file. I don't know what it does with the extra arguments. You'd have to look at the documentation for unzip, right? There is no sys220.zip there's no file called sys220. Unzip will add the .zip extension for you if you forget it, right? And so it doesn't find any one of those files, and so unzip complains, and then your command doesn't run. Right? So we need to stop. In this case, we want to stop word splitting from happening, so we need to surround this with double quotes or single quotes. Right? Double quotes will suppress word splitting. Right? Single quotes suppresses the special meaning of everything, so all of this is treated as one string, right? Or you have to go back and escape all of the space characters. Right? So all of those in this case work, right? Those all stop word splitting from happening on this argument, and now unzip will hopefully run. I don't know what's in that zip file. Is it even a zip file? It's not even a real zip file. It's just a made-up file. Okay, so right, so that's when you run into problems involving spaces in a argument, it's probably the word splitting is happening and something now strange is happening to your command. Right. Okay, so word splitting by default happens on white space, but you can change what characters are used to split. Right. So there's a variable called all caps IFS. So that's the internal field separator variable. It stores a string. The characters in the string are all will all cause word splitting to will be the delimiters for word splitting. So if you don't touch IFS, it contains the characters space, tab, and the new line character. Right. You're allowed to replace the contents of IFS if you want to. Now, if you do this and you forget to set IFS back to the space, tab, and new line character, any subsequent command that you run will now use your replaced characters to do word splitting. And so that's probably going to break a lot of stuff that you do later on. So you have to remember, if you're going to change IFS, you have to change it back. So here, I've got a string, right? So I'm going to make a string, a variable called str, right? I'm going to assign it some stuffing quotes, right? So the quoting here is important, right? I want to preserve all of these spaces, the new line characters here, here, and here, right? So in order to actually store this string as it's written in a variable, I need to quote that, right? So that works, no problem, right? So the value of string, to get the value of string, I use $str, right? Or $brace str, closing brace, right? Now if I print this, you don't get this. Right? Instead, you get that, right? And so you look at this, and you say, well, what the heck happened, right? I defined string properly up here, right? Now down here, it tells me that string is field 1 space field 2 space field 3 space field 4, right? So what's happened, right? That's a parameter substitution, right? So this that substitution occurs before word splitting occurs, right? So all of this replaces that. Sorry, replaces that, right? What does this contain? Well, it's got a bunch of spaces here. So when word splitting happens, right, it takes the field 1 and says, hey, there's a token. So it drops field 1 into here, right? Sees a bunch of spaces, right? Sees field 2. So now it drops the string field 2 into here. So it's now field 1 space field 2, right? Sees a bunch of white space. So it replaces all the white space with a single space and drops field 3 into here. So now it's field 1, field 2, field 3. Sees a bunch of new line characters here, replaces it all with a single space, and then drops field 4 into here. And so when you type in that, it's as though you had typed in field 1, field 2, field 3, field 4, right? Whatever was there gets replaced with all of this. Word splitting occurs, so all of the multiple spaces get merged into a single space, and that's what you get to echo, right? And so echo prints out that. So put that back, $. Okay, so all the multiple spaces, they all get merged into single spaces, and then the contents of the string just get substituted in for the parameter expansion here, right? So how do you solve this? Do I show you how to solve this? Okay, so how can you solve this? Well, I know that double quoting stops word splitting from happening. So what happens if I do that? I get that, which was the original string, right? So double quotes prevents word splitting from happening, right? It doesn't prevent the parameter substitution though. So the contents of string gets dropped inside the double quotes, right? Word splitting no longer happens on the contents, and so now you get the string as it was originally written, right? So whenever you're using the double quotes to access the characters of a string, there's a good chance you might need to double quote it if there's any special characters in it, right? Remember, there can be other special characters in here as well, right? So you have to be careful about those other special characters. Okay, every once in a while, you might come into a situation when you say, hey, it would be nice if this didn't split on spaces, but it split on something else, right? So here I've got a string that contains this is supposed to be a student number, comma, last name, comma, first name, right? So you might say, hey, look, I want to get the first name out of this string, or I might want to get the student number out of the string, or I might want to get the last name out of this string. It would be nice if I could split this string at the commas. If you wanted to, you can use word splitting to achieve this for you. So the idea is, now remember, word splitting happens all over the place in Bash, right? So if you ever change IFS, you're going to want to change it back when you're done, right? Otherwise, it's going to split on the characters that you set instead of going back to splitting on spaces. So remember what the current value of IFS is, right? To get the current value, I need $IFS, right? Now I'd like to split on commas instead of spaces. So now I can replace the contents of IFS with a single comma, right? And now I can echo out that string, right? And then after I'm done, I can replace it, I can reset IFS back to its original, right? So this gives you 1, 2, 3, 4, 5, 6, space, Esther, space, Polly, right? Now I can use cut to process this if I wanted to without having to specify the delimiter, for example, right? I can also use a loop to process all of the fields, right? So here's our first example of a loop. Don't worry if you don't understand what it means. There's a whole notebook on this later on, right? I'm going to do the same thing to that string. This time I'm going to loop over all of the words in that string, right? And so the way you can do that is to write a for loop, right? This looks like a lot like a Python for loop, right? For each field in that string, do something with it. This thing here is just a list, is what Bash calls a list. So it's a white separated space, it's a white space separated list of strings, right? Field will process each one of those individual words separately. Sorry, the for loop will process each one of those individual words separately, right? So each time through this loop, field is going to take on, in this case, 1, 2, 3, 4, 5, 6, right? Second time through the loop, it'll be Esther. Third time through the loop, it'll be Polly, right? So there you got 1, 2, 3, 4, 5, 6, then Esther, and then Polly, right? And of course, instead of just printing them out or running them through a loop or something like that, you can take the string 1, 2, 3, 4, 5, 6, Esther, Polly, right, and pass it to some other command to process it instead, right? You could pass it to cut to extract the first, to get student number, last name or first name, or something else, right? Okay, so it turns out that, so in many cases, or most cases, you can get by knowing just what I told you about word splitting. It turns out that the rules for describing the exact behavior of how word splitting works, it turns out they're very complicated. So if you click on that link there, you can get all the gory details of exactly how word splitting works, or what the rules are surrounding it, if you're interested. Right? You don't need to. You don't have to rely on this information on a test or exam or something like that. Okay, finally, file name expansion. So whenever we use wildcards, that's actually an example of file name expansion. Right? So if you use star or the question mark or the square brackets to match a file name, it's file name expansion that's happening. File name expansion happens after word splitting has occurred. Right? So it's the last expansion that happens. Right? Okay, so we've talked about file name expansion before. We don't need to talk about it again. Does anybody have any questions about how expansions work? Right? So yes.
Does the IFS
Yeah.
go back to normal?
Nope. Oh, yes, yeah, so when you close a terminal, yeah. So every time you close and open a terminal, you get a new instance of the terminal. So IFS will get reset. Yeah. Any other questions? All right. So the important thing to remember about an expansion is the value of the expansion replaces the expansion itself, right? So that's the thing that you have to remember. That's what an expansion is in Bash. All right, it's 10 after the hour. I don't really want to start the next notebook. So the next notebook is, oh no, we can do this. It's Introduction to Bash. This is easy, so we'll do this. All right, so you now know a fair bit about Bash, right? You know how to use commands. You know a little bit about the basic expansions, right? So you can motor around on your command line and manipulate your file system and do some work, right? Assuming you know which commands to use. The next part in this course is that I'm going to show you how to write a little Bash program, right? And so Bash programs are called Bash scripts, right? There's nothing special about a Bash script. It's just a bunch of commands in a file, right? That's all it is. It's just a bunch of Bash commands. They're executed in the order that they appear in the file, unless it's a function, right? Okay, so Bash script, it's just plain text, right? So like any other programming language that you've used, it's just plain text in a file somewhere. When you quote unquote run the script, right, the shell reads the file, it interprets the commands that are contained in the script, right? The shell, oh, sorry, never mind, that's fine. So in order to run a script as though it were a command, right, the current user has to be able to read the script, right? So they need read permission on the file containing the script. Right? Furthermore, they need execute permission on the script. Right, so remember, execute permission is the type of permission that lets you treat a file as though it were a runnable program. Right, so you must have read and execute permission on a script. Finally, the operating system needs to know where the script is located, right, because it's treating it as a command. Right, so let me show you what I mean by all this. This directory is a mess, so I'm going to go up one, and I'm going to go to introduction. Is there anything here? Okay, so there's a bunch of scripts in here already, right? They're shown in green in my terminal. The fact that they're shown in green means that they are executable. So the execute permission is on all of these, right? Your terminal might behave differently, right? So they may not be colored in, or they might have a different color, right? It depends on how your terminal is configured. So these are all executable to me. They're also all readable to me, right? So I'm the owner. Notice that I have read, write, and execute permission on all of these commands. So for example, I can run the command hello.sh as though it were, so I can I can treat hello.sh as though it were a command and run it. Right? Now, the third part, so I have read permission on it, I have execute permission on it, but the third part, I don't necessarily have, I haven't necessarily taken care of that yet. Right? So the third part of this is that my operating system needs to know where does this command live. Right? So so Linux has a variable called path, all caps. Right? So the path variable, if you look at it, it's just a bunch of directories. Right? So that's a directory, then there's a colon. So the colon in the path variable is the directory separator. Right? That's a directory. Right? Colon, that's a directory, and so on and so on and so on and so forth. Right? When you type in a command into bash, right, bash looks in all of these directories in the order that they are in to figure out which command you want to run. Right? So if there's a command or a file in my home directory /bin, right, called hello.sh, I could actually run that command. Right? Okay, so the weird part in bash is that the current directory is not part of the path, and there's no way that you can add it to the path either, I don't think. I should check that. I'm not sure if that's true. Right? But the current directory is not part of the path. So if I type in hello.sh, the shell complains. It says, hey, I don't know what this command is. Right? And it's because none of these directories have a file in it called hello.sh. Right? So what do I really want to write? Well, I know hello.sh is in the current directory. So if I tell the shell, hey, I want to run hello.sh in the current directory, maybe that'll work. So how do I tell it? How do I specify the file hello.sh in the current directory? Well, dot is the name of the current directory. Right? And now it works. So when you go to run your command that you created yourself and it's living in the current directory and you want to run it there, right? You're always writing / name of the command. Right? The alternative is to put it somewhere on your path. Right? So for example, I could have put it here, and if I did, it would work just fine. Why don't I put it there? So how do I put it there? So I can put a copy of it there. So I can copy hello.sh to home Burton bin. Right? There's the copy command from last lecture. Right? Now I can type in, well, I should be able to type, oh wait, is this gonna, yes, it does work. Right? So now I can type in hello.sh and now it works because my program happens to be, there happens to be a copy in that directory. I can still run the one in the current directory, right, by writing that. Right? So that works too. Okay, so that's the path. And so when you're doing your assignment, if you try to run a script and your shell complains it doesn't know where that script is or that command, or does not know what that command is, check to make sure you can read the file. You can probably read the file, right? Check to make sure that you can execute the file, right? And then make sure that you're running the file by specifying where that file is located, right? If you take off any of these permissions, the file won't run. So change mode. So I'm going to remove read permission, execute permission from, sorry, u-x. So take away execute permission for the current user on that file. If I try to run it, it complains, there's permission denied. Right? It doesn't tell you which permission is denied, it just says permission is denied. So it's not the most useful error message in the world. Okay, I'm going to put it back, and I'm going to take away read permission. So u-r on hello.sh, sorry, hello, right? Try to run it again, right? And again, it tells you permission denied. Right? If I try to run the one that's in my other directory though, in home Burton bin, that still works, right? I haven't changed the permissions on that file. Okay, so you can name your script anything you want, right? Bash doesn't care, right? It's just a file name. By convention, many programmers will name their shell scripts .sh, right? So the extension indicates that it's a shell script, but that's not a universal convention. In this course, I'm always going to name everything, all of our scripts with .sh. On the assignments, I would ask you to do the same thing. When the TAs run their testing scripts, they're going to assume The testing scripts are basically bash scripts that try to call your programs, right? If your file name doesn't have the .sh extension, when we try to call your program, it's not going to work. Use lowercase letters and numbers in your file name, right? Multi-word, yeah. If you have a multi-word script name, you can use an underscore to separate the words if you want to. I don't think I actually follow this rule, actually, in this course. I think a lot of them, I just mash everything together. But anyway, the assignments will tell you what should you name your scripts, right? Okay, so when you go to write your script, the first line of this script is significant, okay? So the first line of your script should always look like this, or if I can remember what it is, user bin env bash, like that. If you're on a Mac, you want to write that. If you're in Linux, you can write this and it usually works. If you're on a standard Unix machine, you can always write the previous version that I just showed you, right? So hashtag exclamation mark slash, make sure I get it right, there. Hashtag exclamation mark root bin bash, no spaces anywhere, right? So the first line of your script tells the shell what program should be used to interpret the rest of this file, right? So when you write that, right, the shell says, okay, I'm going to interpret the rest of this file using the interpreter bin bash, right, which is bash. Right? The interpreter is just a program that reads the contents and interprets it, and reads and interprets the contents of the file. That's what the hashtag exclamation mark means, right? It's an indication that the rest of this line specifies the interpreter for the rest of this file. This thing up here says use that command there, so the env command, to use the to run the bash, to run the program called bash to interpret the rest of the file. Right? Mac doesn't put bash in the directory root root bin, which is why you need to write that. Right? Your Mac operating system puts bash somewhere else. env knows where it is, and so that's what that is doing right there. Right? You can use either in this course. It should work on Linux as well. This should work here, right? It does. Okay, so either one works. If you're on Mac, use that version there. Right? Okay, so all that's happening here is, right, your shell reads the first line. It says, oh, the rest of this script is bash. So it's going to use bash to interpret the rest of the script. This is just echo, which prints out a string. So it just prints out the string. There's nothing else left, so the script stops, and that's it. So there's an example of your first bash program. In Jupyter, you can run a script within the, you can run the script within, right. Jupyter can run the script. Yes, so Jupyter can run this as though it were a script. What you can't do, there's something that you can't do. Anyway, never mind. So I guess we're out of time. So in the next class, I will show you all the steps you need to take to create this file and run it on your computer. Right? Assignment 2 should come out in the next day or so. Right?